In the last video, we checked to see if there were any interaction terms. And now the question is there an effect due to the BD treatment? But we could only ask, oh, wrong one, that one. Is there an effect due to the BD treatment? However, we could only ask that question if we had checked to see if there are interaction terms. And remember, we were checking to see, are these two slopes the same? That is there an interaction? If their slopes are not the same, then it's roughly parallel. And what we determined when we went through that process last time, that beta 3 was essentially 0, was the confidence levels in 0. So we failed to reject, and so we don't really need beta 3 within our response, or within our linear model. So is there an effect to the BD treatment? So the null hypothesis, there's no main effect to the BD, versus the alternative, there is a main effect, or equivalently that a beta 1 is 0, or alternatively the beta 1 is not 0. We can eliminate the predictor variable x1, or the predictor x1 is needed. Now we could still do a partial F test, but because we only have one beta, we could do a t-test. And let's go ahead and do a t-test on Minitab. So what our regression is going to be then, because we have a new model, remember, our new model, because we got rid of the interaction term, is just beta 1, or has x1 and x2 in it. So let's go ahead, and in this case we're going to get rid of treatment x3. Better make sure that we don't have interaction terms. We go to my model, and okay, good, no interaction terms in there. And let's make sure we've got the graphs, we've got the 4 and 1. We don't need the x3 versus residuals, we just need treatment in time. So let's go ahead and do that. We'll quickly skip down to the residuals. Ooh, this doesn't look good. There does appear to be a pattern here, so that's not good. And the residuals versus treatment may be okay. The normal probability plot, we may want to go and look at the one that gives us the p-value, but we're just checking that just to remind you of that. So we're trying to see if the treatment works or not, and so we look at the treatment, we get a t-value of 1.83. Sorry, the treatment 1.83. 1.83 minus 0 over 0.404 gives us 0.077. That's above our significance level, and so we would not reject the null hypothesis and conclude that the data do not give evidence sufficient to say that the treatment affects the response. Now, just remember that point at this time that we had this example where the treatment did not appear to affect the response. There's a lesson in there. Okay, so the question is there an effect to the predictor variable time? Again, beta 2 is 0, beta 2 is not 0. Let's go ahead and take a look at it, because we're only looking at 1. We don't have to do a partial F test. We just use 1. If we wanted to, we could use a partial F test. Our coefficient is 0.0661 minus 0 divided by 0.00712. We get 9.26. Our p-value is 0. We can reject that null hypothesis. And in that case, for time then, we would have data sufficient saying that it does go. If I said for treatment it should be 0.740 divided by 0.404 for 1.83. I don't know why I had the t-value earlier, so you can rewind and see my mistake. Okay, so what we've done then is come up with a model and said, well, we'd keep time in this case. Now, in the next video, we're going to say, what happens if we have quadratic terms in our model? So stay tuned.